Okay, starting where we left off, now let's look at mortality or ways to reduce our population. Death is often expressed in a percent of the population per year, our mortality rate. And we can have various types of mortality. We could have natural mortality. We could have some anthropogenic mortalities like harvesting, and then we can have total mortality for a year. And we might report those numbers differently. So we might report only harvest mortality, or we might report only natural mortality, or we might report it as a total. So the question then is mortality affected by density dependent or density independent factors? Well, I'm going to skip that question. That depends, and we need to understand density dependence, and we'll get to that here in a second. But most often our mortality rate is over 1 year, and we need to know and understand that survival rates and mortality rates are conversely related. So if you have a 20% mortality rate, you have an 80% survival rate, or vice versa. Longevity is how long that animal tends to live, the age of death of an average member of the population. For some, maybe some small mammals, it's maybe a couple months. For others, it might be 8 years or 10 years or even 15 years. Population decline can be due to both mortality and emigration with an E. That's animals leaving that defined area that you were including for the population. And mortality is often age and sex dependent. This is really important. For most of our species, it is more difficult for an animal to be a male. So especially with our mammals, our deer and our elk and our moose, mortality is much higher for the males. They typically have to go farther, they have to eat more, they spend more energy, and for our ungulates that are growing those antlers all year or all winter long, that takes a lot of energy that then they aren't using to put on fat or to keep on fat. So mortality can be much higher in males versus females. And of course, age, right? Our mortality is much higher usually with younger animals and with older animals. So we've been mentioning this idea of density dependent factors, and I think your book does a really good job of explaining this. So hopefully I'm just adding to what you already know. But environmental factors that affect a population based on its density. So what are these density dependent factors? Well, food, right? If we have more individuals eating, then we only have a certain amount of food growing, then essentially the amount of food available is going to be dependent upon how many animals are trying to consume it at once. So that would be a density dependent factor. And the same could be true for water. Of course, that might be dependent upon how much water is available to start with. It may not be density dependent, but it sure could be. Shelter, the amount of habitat available for shelter could be dependent on how many animals there are in the population. And this is a really important thought, and your book does a great job with this concept of inversity. So inversity says that when in population density is low, you may actually get higher reproductive rates or higher instances of twins. And you might get instances where animals are reproducing at a younger age. Maybe they typically don't reach, they don't breed in the population until year 2. But if you have very low numbers, they might breed at year 1. And so both of those would be density dependent, but in a kind of a reverse kind of thinking that the population is going to grow more quickly through reproduction when your densities are lower. And your book gives some good examples like coyotes. They do this. If we try and depress the populations by killing adults, they're just going to have more young. So that inversity comes into effect. And I feel like we're seeing this with our moose population in Colorado right now. And I've heard a number of accounts of not just a moose having one calf, which is common, but they're often having twins, which is not uncommon. But what we're seeing with a lot of our moose is they're actually having triplets. And then so some of our populations of moose in some of our areas of Colorado, our biotic potential is kind of following that J curve right now because they are having a lot of young because they're have found habitat that could support a lot more moose. So those are some just some ideas on density dependent factors. Um, and then the other thing that we might see here with inversity is that if population density is high, then you might see fewer females actually reproducing in a given year and fewer number of young being born. Now, this is kind of a weird thought here, but why might this happen? Why do we see this? Well, you could theorize however you want, but this is one way of nature kind of staying in balance, is if we have good conditions and we could handle more animals can be born. And if we're already competing for resources, then maybe we don't produce more young the next year. It kind of comes back to some of these factors up here too. And you think about the individual fitness of a female. If a female is in really good body condition, her body can support more young and more offspring. If it is not in good condition because competition is tough and maybe they're not getting as much food as they could, then she might not be fit enough to reproduce that next year. So it's a good method of kind of checks and balances and keeping things under control. But then we also have these mortality factors that might be density independent. These are environmental factors that act independently of a population density. So things like natural disasters that come through. A density independent factor can be any factor that limits the size of a population whose effect is not dependent on the number of individuals in that population. Maybe a mudslide that kills everybody on the slope, or a flood in a river that washes out all of the young of the year and most of the adults. Those can be independent factors. So here's a thought. Would a disease be a density dependent or a density independent factor? That's a tough one, right? Because a disease could kill an animal regardless of how many animals there are in that population. So you could definitely make the argument that it is an independent factor. But what do we know about diseases? Often, if the density is higher, they may spread more quickly throughout the population. Thus, your chance of catching that disease might be highly dependent upon how many are in the population. So disease is a tricky one to get at and could go either way. Okay, remember when I said that it's so important to understand your carrying capacity, because if you exceed your carrying capacity, you could see a massive crash. And what you're looking at here is the population of deer in the Kaibab Plateau in the early 1900s. So we had an area that our land managers at the time, albeit we had a brand new Forest Service, we had brand new idea of public lands, but the sentiment toward predators at this time was that if we could remove predators, that would be a limiting factor. And they didn't have these concepts theorized yet, but it just made sense. If we got rid of predators, we could have more deer. And so that's exactly what they did. They got rid of most of the predators on the Kaibab Plateau. So you can see where our population of deer was in 1905. They think it was way down here. And we started eliminating predators, and we see this population going up. This is starting to look kind of like that J curve, right? But right about here, we started realizing that this line, in this kind of an odd shape, but this is probably around the carrying capacity that area could have supported at that time. We start seeing damage to habitat, and that's kind of the first sign that we're exceeding our carrying capacity. We're seeing that the plants that those animals are depending upon are having a hard time responding and coming back. We're getting overgrazing occurring. Well, they noticed around 60,000 deer, the population at about, this is in thousands, at about 60,000. We have a deer starving. We start getting a few more warning signs that we got something bad coming in. And then this population exceeded 100,000 individuals. And at that point, it was not a slow decline. It was an absolute crash. And in 2 winters, we got 60% of the deer dying. So you can imagine 60 1,000 dead deer in this very small area when we shot past our carrying capacity and then had a couple hard winters in a row where everybody died off. We get all the way down to 40,000 animals, and it didn't stop there if we had reduced them early, but now we have all these deer in super poor condition because they've been competing so much with each other, and we get that population all the way dropping back down to about 10,000 animals. This is a classic example of what happens when we really mess up that predator-prey balance, but also what happens when we exceed our carrying capacity. So how do you know if you have too many animals? Well, that's the idea here, is that if you've done research on what are some signs of overgrazing, overbrowsing, are you seeing some effects on the habitat of having too many, or are you seeing some effects on a prey population, maybe of having too many predators? That can give you an indication that you might be exceeding your carrying capacity, setting yourself up for a situation like this Kaibab Plateau situation. Is an extreme example, but an example nonetheless. How do you know if you have too few animals? That's another question. Now you're not going to see the impact on the habitat, but you might see um, maybe an increase in number of young being born. That might be a situation. And what are the consequences there if you have too few animals in the environment? Well, again, there's a chain reaction to everything. Everything's connected. So you have to maybe look wider than the species of interest. Okay, I should mention in part of your homework assignment we'll be looking at the wolves and elk interaction in Yellowstone, but this is an example where if you have too few animals of maybe a predatory species, that your prey species then can have a dramatic impact on the vegetation if nothing is in there to help control them. Um, that's a really big situation, the wolves and elk in Yellowstone, and it's more than just, okay, there weren't any wolves, and so the elk ate too many willows, and so it changed the ecosystems. Yes, but it had far-reaching impacts, and hopefully we'll be able to get into a little bit more into that this semester. But this paper that I'm going to ask you to read, or this chapter out of a book, is a really good place to start in looking at just what impact not having enough of a species had on an entire ecosystem. Okay, we're going to stop here at the idea of harvestable surplus because I'm running out of time and I don't want to cut this off in the middle of this piece. So we'll continue with harvestable surplus and we'll wrap all of this up in just a couple of minutes with part 3 of today's lesson.